The Enalysis system is designed to use basic compressor operating parameters and conditions to provide a cylinder-by-cylinder detailed analysis of the operating and maintenance opportunities on each of your individual compressors. In this webinar, we will review the correct data sampling procedure for a reciprocating compressor. The data collected from the compressor should be recorded on the Enalysis Field Data Input Worksheet provided by Detechtion Technologies. This form can also be downloaded off of the Detechtion website at www.detechtion.com and clicking on the View Enalysis PDF Forms link and selecting the Recip Field Data Input Worksheet. Upon arrival at the compressor site, the unit number, compressor name, production area, and unit location should be recorded on the form. This information should never change unless a compressor has been moved. The overhaul hours and downtime hours should be recorded. These hours and dates are typically taken from the compressor logbook. The data required includes the hour meter reading for the unit, any scheduled and unscheduled downtime hours since the last report, date of the last oil and filter change, date of the last top end overhaul, date of the last bottom end overhaul, and date of the last major compressor overhaul. The compressor flow is the inlet volume to the compressor, which should be read from the inlet meter on site. This should be the instantaneous flow at the time of your readings and not the average daily flow from the day before. If an inlet meter is not present, or the meter at a plant location is for more than one compressor, an estimate of the expected flow through the compressor should be recorded in this field. It is important to note that the Enalysis program does not require an accurate flow measurement to perform all of the necessary diagnostic calculations. The station inlet pressure is the pressure at your inlet header located at the furthest point upstream of the first stage of compression. This pressure can be read from a pressure gauge or with the use of a digital deadweight gauge. If this pressure is not available, then enter the current stage 1 suction pressure into this field. The speed is the operating speed of the driver. The Enalysis program will automatically take into account any gear increaser or reducer between the driver and compressor. The engine turbo boost is the current manifold pressure on the driver. This pressure can be recorded using a variety of units of measure, as long as the units used are recorded on the field data sheet. The engine turbo boost can be trended against calculated horsepower use, which in turn is an effective indicator of the health of your engine. Examine the bypass valve and record the percentage that it is open. On some units there is a digital or analog gauge, but if not, then an approximation of its position is fine based on visual inspection of the valve. The bottom half of the field data sheet is where the actual operating conditions of the compressor are captured. On a reciprocating compressor, the field data is collected and recorded for each cylinder individually. Record the stage number and throw for each cylinder. The cylinder action must indicate the current setup of the machine, indicating whether each cylinder is double acting with all valves installed, single acting on the head end, single acting on the crank end, or non-acting with all suction valves removed. The head end pocket adjustment is the amount that the head end pocket is open. To determine the pocket position, it is best to screw the pocket fully closed while the unit is down and record that position on the pocket threads with spray paint. The pocket position is recorded as the distance from this mark to the reference point. The head end and crank end spacers are the number of valve spacers or split yokes that are currently installed under the suction or discharge valves on either the head end or the crank end of the cylinder. The suction pressure for each stage should be recorded from the suction pulsation bottle or as close to the suction side of the cylinders as possible, as there can be orifices, valves, or suction screens which may induce significant pressure drops, causing erroneous results on the Enalysis report. The discharge pressure should be recorded from the discharge bottle using a digital deadweight gauge as mentioned earlier. These pressures should be measured using a digital deadweight gauge for best accuracy. In order to facilitate the collection of the pressure readings, many Detechtion clients have built a manifold onto their control panels with appropriate tubing, valves, and quick connectors to take all of the required pressure readings with a digital deadweight gauge. If this is not possible, then the pressures should simply be recorded using traditional panel gauges. If you would like to learn more about the benefits of using digital deadweight gauges, please review the compressor tech tip dated December 15, 2006, found on our website. Temperatures should be taken with an infrared heat gun on a dot of flat black paint provided by Detechtion's engineers at the time of audit and initial setup of your compressor on the Enalysis system. Paint color can affect the readings on your gun by as much as 50 degrees Fahrenheit. Heat guns are calibrated to record the absolute temperatures of black bodies, which is what our system requires. The suction temperature should be taken on the piping upstream of the suction bottle as marked by the black paint dot to reduce the effects of thermal conductivity from the cylinder and the effect of any heated gas that has slipped back through damaged suction valves up into the bottle. If no suction bottle is present, then the temperature should be taken 4 to 8 feet upstream of the cylinder. The discharge pressure should be recorded from the discharge bottle using a digital deadweight gauge as mentioned earlier. The discharge temperature should be taken using an infrared heat gun on the neck between the cylinder and the discharge bottle. If there are multiple cylinders on one stage of compression, it is critical that discharge temperatures are recorded for each of those cylinders. The completed field data input worksheet is now ready to be entered online for the Enalysis report to be instantaneously generated. When you log into the Enalysis website, you must first select the style of compressor you are submitting data for by choosing either the Recip or Screw tab at the top right of the screen. Next, you must search for the specific unit you are going to enter the data for. This is done by clicking the search button at the top of the screen. The unit can be searched for by unit number, unit location, compressor name, or serial numbers. Once the unit has been selected, click the Enter Field Data link and a form will come up that is similar to the layout of the Field Data Input worksheet. The data can then be entered by filling out each of the fields on the website. It is critical that the fields are entered using the correct units of measure, whether they be metric or imperial. If the field data has been recorded using metric for some measurements and imperial for others, the units can be toggled during the input session using the Current Unit Selection button. Using this toggle, you can convert that data by switching the Current Units button to the units of the data that needs to be entered, entering the data, and then changing the Current Units button to the correct units for the rest of the form. In order to speed up the data entry online, the Tab button on the keyboard can be used to advance between cells on the field data entry page. Once all data has been entered on the form, the Save button must be clicked, and an Enalysis report will be generated within 2 to 5 seconds for you to review.